yesterday's as well as previous day videos. So the videos are available in the registration link, and the link is shared in the chat window. All of you use it there. So, and also you have to mute your audio and video throughout the session, and kindly join via your login credentials, because the attendance is tracked using your credentials. Greetings from SXCC. I welcome all the participants for the third day of the FDP on cloud computing. So last 2 days we have discussed about virtual machine installation and also Google App Engine. So today we are going to see about simulation of cloud scenario using Cloud Sim and also scheduling algorithm using Cloud Sim. So let me introduce today's resource person. Today's resource person is Mr. Bright Jose, Assistant Professor, working as a Assistant Professor in Computer Science and Engineering, St. Xavier's Catholic College of Engineering. He is our alumni. He did his UG SLS PG in St. Xavier's Catholic College of Engineering, and now he is currently pursuing his PhD at Anna University. He is an active researcher. His research areas are cloud computing, machine learning techniques, and an active placement coordinator of CSE department. And he is in charge of IEEE student chapter as well as Institute collaboration cell. So with this introduction, let me call Bright Jose to handle this session. Right, sir?
Yeah, ma'am. Thank you so much, ma'am, for the introduction and introducing myself. So myself, I am Bright, and, working as assistant professor from CSE from St. Xavier's Catholic College of Engineering. So good morning, everyone. So today we are going to see about the Cloud Sim. It is a cloud simulator. Okay, I'm just sharing a few things in cloud simulators. So this is my today's agenda. And the first part we are just saying the basic introduction about the Cloud Sim. Then second part is software requirements and how to install or how to configure with the softwares. Then third let's see some few things about programming basics. And the next one, we can run the programs through Cloud Sim, and finally we can go for the queries if you have any. Right. So let's start with some basic introduction about the cloud. I think so. Most of us know the cloud computing, right? So in nowadays the cloud computing is a big research area. Now most of them are doing the researchers in the cloud computing area, right? And you all know about what is cloud computing, the basic definitions. So cloud computing, it is providing a lot of resources to the users on on-demand basis, right? So that is, it is a paper usage model, and every cloud computing or every cloud service providers are providing infrastructure as a service. They are providing platform as a service and software as a service, right? So in the software, in the infrastructure as a service, you can get a lot of computational devices. You will get, and platforms, you will get a lot of softwares, and you will get the platforms where you have to run your programs, then the softwares also, right? So how to do this cloud computing, or how to execute our tasks, or how to host our applications, okay? So for that we need a lot of workstations. So workstations are nothing but it is a huge amount, it is a huge network collection of computational resources, okay? So it is also comprises of supercomputers, or maybe the normal nodes, or maybe the big servers are interconnected, and they are providing it is a huge volume of computational resources. So the computational resources means you can find huge amount of random access memory. You can find out a huge amount of processing element, Uh, and you can find out the huge amount of storage devices also, and everything are interconnected. For to run your application, sometimes we can expect these three things, right? Maybe your application sometimes your application only expects only the storage, or sometimes your application may expect the random access memory and processing elements and storage area also, storage devices also. Okay, so this is the very basic introduction about the cloud computing, right? So next, let's we move to the cloud SIM. And in today's world, then most of them are doing their cloud researches, and so through this cloud SIM software, through the cloud SIM software, you can simulate something, or you can simulate some kind of executions in the through this cloud simulators. Okay, so cloud SIM is a framework for modeling and simulation of cloud computing infrastructure and as well as services. And this cloud SIM is it is an open source software, and the open source software is developed by the clouds laboratory. Okay, so this is our clouds this is designed by the clouds laboratory, which is in Melbourne, Australia. And so cloud sim is a most popular version. So nowadays there are a lot of alternatives are there with this cloud sim. And in this cloud sim there are various versions also available. So now the current version is version 5.0, and the initial version is the 2.0. Okay, right. So cloud sim. So next we'll see about the next. So cloud sim, what are the features are associated with the cloud sim? So the cloud sim is providing a platform to run your applications in the cloud scenario, right? So usually in the initial slide itself, I explain about the cloud computing. So the cloud computing is a huge collection of network resources. Okay, so it is a huge collection of network resources. So in the network resources, we have to interconnect all the machines, and we have to create so usually in the cloud scenario, we will create a number of virtual machines. I will hear about these kind of keywords. You may hear about the words, it's like a host, you can like then virtual machines and all. We studied in cloud computing. But in cloud sim also, again, it is also providing the same kind of activities to the users, those who are doing the simulation in the cloud sim. So in the cloud sim, there are lot of predefined classes are available. There are lot of softwares. There are lot of built-in jar files are available, which is supporting your cloud applications. Okay, so it is supporting a lot of things. First one is it is support for modeling and simulation of large-scale cloud computing environments, including data centers on a physical machine node. Then why we are preferring with this cloud simulations. So if you want to execute a job in the real cloud scenario, we need a big system, or we need a huge system. It's like a supercomputer, or we have to go with the big servers. Okay, so in that case we have to go with we have to purchase, or we have to install all the softwares, etc., etc. But when we are going with the cloud sim, a single system is enough. And through this cloud simulator, it is providing all the resources what we are doing in the supercomputers, or what we are doing in the servers. So we can do all such things through these cloud simulators, right? And it is a self-contained platform for modeling clouds, then service brokers, provisioning and allocation policies. Because so most of the experiments are related with the scheduling algorithms, maybe the processing. So these kind of activities only we can do with this cloud sim simulators. Okay, so lot of things we can do it. Then we can do the virtualization, because we can create a data center through this cloud sim. There are inbuilt classes are available. Okay, we have no need to go with others. There are a lot of inbuilt classes are available. So through that we can create all the entities through this cloud sim. Okay, so we can do all the activities, the simulation activities we can do with the cloud sim. So these are the basic features in the cloud sim. Okay, so before writing your code, Okay, so you should know about the basic things in the cloud sim. So usually the cloud sim has three layers. Okay, so the first layer is usually call it as it is a cloud sim core simulation engine. Actually, your programs will be executed with the help of your Java as well as your Java virtual engine as well as your cloud core simulation engine. Both are combined, and that is going to execute your actual code. Okay, so that is under the bottom layer, that is under the bottom layer. Okay, and in this the second layer, just to take it to the second layer, this is the cloud sim. I told that the cloud sim is a Java based, it is a pure Java based simulation software, right? So in the cloud sim itself, it is providing lot of predefined classes, right? So we can use it while executing your code. Okay, so usually we will write a code. For example, I'm just giving one example. We will write only the lines of code will be around some 50 to 100 or 200 or 300 only. So that is your actual code. But while executing the code, actually some thousands of lines of code will be executed by your cloud sim core simulation engine as well as your Java uh, machine, Java engine also, right? So most of the supporting softwares, most of the supporting classes will be available with this cloud sim. Most of the supporting classes will be available in the cloud sim. And while writing your code, you have to inherit or you have to extract the characteristics which is available in the middle layer. That is actually it is we are taking most of the things from the cloud sim core components. So usually these are the cloud sim core components. So one is a network, and next one is the cloud resources, next one is the cloud services, and next one is the VM services, and next one is user interface structures. Okay. So within that, you can see that a lot of small boxes with some names are also available. This is a cloudlet, then virtual machines, then cloudlet execution, then VM management, VM provisioning. So CPU allocation, there are inbuilt classes are available. There are inbuilt classes are available. So while creating your program, while executing your program, you have to you have to inherit or you have to extract something from this cloud sim only. Okay, this is the core area. So we have to extract something from this cloud sim middle areas. And the next one is we have to think about this user code, and this is the user code. While you have to write all the codes within this area only, right? So this is your simulation specification, and you have to write your scheduling policy and everything we have to mention and here itself. I told that. So this is your core area. From this predefined classes only, using these predefined classes only, you have to extract or you have to inherit the classes. You have to inherit the classes, and you have to write the code from in the user code. Okay. So, and you can create your cloud scenario. You have to create your cloud scenario. You know the cloud scenario. For example, I want to execute my job with the following specifications. For example, I need a data center. I need a data center with 5 hosts. I need a data center with 5 hosts, and I need some the 20 core processors, and I need some 10 GB of RAM, or maybe some 20 GB of I need some 20 GB of RAM. So all these things, that is the cloud scenario. So that is developed by the user. Okay, so that is everything is up to users only. The user has to decide how much amount of memory you needed, and how much amount of process elements you needed, and how much your task, how much instructions you are going to write, and what is the input file size and what is the output file size, how we are going to schedule, and everything we have to write it in the user code part. Okay, so this is the cloud simulation architecture, and so this is the actual explanation what I have given now. So this is the cloud simulation engine provides support for modeling and simulation of virtualized cloud-based data center environment. So everything they are giving. Then the second one is a cloud sim layer. It is providing dedicated management of all the virtual machines, memory, storage, and bandwidth. and the third one is a user code layer. Here only we are going to write our code. Okay. So next we are just moving to the software requirements as well as the implementation part. I hope the first part I gave the brief introduction about the Cloud SIM. So the Cloud SIM, it is full and fully, it is based on Java, right? So through this Cloud SIM, you can run your cloud simulations. You can do the cloud simulations. So for that, we need the following softwares. Okay. So usually the Cloud SIM, there are a lot of versions are available. Cloud SIM 2, then Cloud SIM 3 version, Cloud SIM 4, and as well as Cloud SIM 5 also available. For our presentation, for today's presentation, I am using Cloud SIM version 3.0.3. For that, it is expecting, the Cloud SIM is expecting the Java version minimum 1.6 and or above. Okay. And for easy implementation of my code, I am using Eclipse IDE, or otherwise I have to use with NetBeans IDE. So in our presentation, so I am using Eclipse IDE, and I need the Cloud SIM softwares also. Okay. So these are the software requirements, and next we'll see about how to install, how to install this Java, Eclipse, and as well as the Cloud SIM. Let's see the examples one by one. Okay. So first thing is we have to download Java. I hope most of them. So is this visible to everyone? Is this screen is visible to everyone?
Right,
Varun sir?
only the PowerPoint is shared.
Okay, so the PowerPoint is shared, right?
Yeah.
Yeah. Okay, right. So now, so I don't have the first thing is I have to download this Java softwares. You can download it from any one of the website. So this is the link. We can directly download the Java from here. So agree and start the download. And if you are clicking this, you will get a installer, Java installer. Okay. So once you got this Java installer, I can show you. So this is the sorry. So I hope I think downloads. We can see it. We'll get a Java installer. Will be like this. I
Right,
think.
sir. If you are using browser, you please share that.
Okay, browser.
Yeah, we are able to see only your presentation.
Okay, now is this visible now?
No, you stop sharing this PowerPoint and start share with the new browser.
Okay.
Right, otherwise share the entire screen.
Okay, sir. Okay, I will do it.
Right, share it, and at the left you may be seeing the desktop. So you share that, so that your entire screen will be shared.
Okay, I have to select the first one, right?
Yeah, left first desktop.
Yeah, desktop. Yeah. Now is this visible?
Yeah, it is loading. Right, please 1 minute.
Yeah.
And now your presentation is visible to us.
Yeah. Okay. Now I am going for that. Yeah. Is it visible now?
Yeah.
Yeah. Okay. Yeah. So those who don't have this Java software, so you please go this website, and you just click this one, agree, and start free download. Okay. If you click this one, and you will get an installer. Okay. So this is Java setup 8.1. So I will show you. So this is the Java setup. Okay. So if you double click it, if you double click it, so automatically the latest version of the Java SDK software will be installed in your system. So that is your first step. Okay. So this is downloading Java. And second thing, so this is secondly, you can also download the Java software from this website also. Okay. And the next one, you have to use any one of the Eclipse version, because a lot of Eclipse Eclipse flavors are available. So go with any one. Right. So I'm just if you go to this Eclipse downloads, so Eclipse is an IDE, right? So in this IDE only we are going to download the Eclipse software. So based on your based on your operating system, please select the 32-bit or 64-bit, and you have to download any one of the version. Okay, so here you can download. Here you can download. So whatever you want, you just download. So I am just selecting this one. So Eclipse IDE 2020-03. If I am downloading, if I am clicking this download 64-bit, again you will get an one installer. Again you will get one installer. So you will be getting get an installer will be like this. So I have just selected this one, Eclipse installer Windows 64. Okay, so there are I have downloaded 2 times, so that's why it is showing 2 times. Okay, so again if you double click it, so keep in your mind, so before installing, okay, so before installing this Eclipse IDE, you must in your system you should have a Java. Okay, you must have Java. So once your Java installation is over, then only you should do with the Eclipse installation. Okay, so once if you got this IDE, once you got the IDE, if you double click it, so automatically the installation process will start. If you click run, okay, if you click run, automatically your cloud sim, sorry, it is not a cloud sim, your what is this? Your Eclipse software's Eclipse ID will be installed in your system. Okay, so once your installation is over, you will get once the installation is over, you will get a window like this. Okay, you will get a window like this. I think you will get a the first page. I think go to tour with Eclipse, like that you will get a message. So in the left side corner, we can go with the file and you can go with the new projects. Okay, so previously I have created everything. So this is the actual GUI of Eclipse ID. Okay, so here only we are going to create our project. Here only we are going to add the cloud sim also. We are going to add our cloud sim also. Right? That means we are just configuring with this Eclipse with the cloud sim. Okay, so this is the second step. So first you should install Java, and second thing is you have to install Eclipse, right? And the third one we should go with the cloud sim. Okay, so because so the cloud sim, so this cloud sim we have to integrate this cloud sim with this Eclipse IDE. So then only you have the capability to execute your programs in the Eclipse software, right? So next I'm just choosing this one. This is IDE. So you can find the softwares from the GitHub. Okay, so this is a very easy way to get all the softwares. Okay, so this is that address. So once the completion of this one, I will share all the links. So it is very helpful for you to download all the softwares. So right now, this is the GitHub Cloud Lab / Cloud Sim and releases. There, here you can find out all the types of cloud sim version softwares. Okay, you can find different types of different versions of cloud sim softwares, right? So if I'm clicking Cloud Sim 5.0, you won't get anything. So only the source codes are available. No need of source code. We need only this one. So we need this Cloud SIM 4.0 SIM and select any one. So Cloud SIM 4.0 tar.gz or Cloud SIM 4.0 SIM. Okay. So for our implementation, I used Cloud SIM 3.03. You can download. Okay, you can download it. So you please select this one. So Cloud SIM 3.0.3 ZIP. So it is in the zip folder. Okay. So if you are clicking this one, automatically the files will be downloaded. Automatically the files will be downloaded. I can show you how it will look like. Right. So most probably, so this is the file. Okay. So this is a file, Cloud SIM 3.0.3. Right. So once you downloaded, so okay, once you downloaded this one, so Cloud SIM 3.0.3, you have to extract it. So how to do the extraction? You have to right click it and you have to do extract files. Okay. So once the extraction is over, so okay, once the extraction is over, so you have to extract it. Once the extraction is over, you will get a folder like this, right? So once the extraction, you just right click it and do the extract files, right? So once the extraction is over, you will get a folder like this, and you just double click it and you can see all the things, right? So here you can see the sources, right? And you can see the jar files. You can see these are the jar files which is supported for the cloud simulations, and you can see the examples. The cloud sim itself, it is providing some default examples, right? Then this is the documentations. Then these are the binary files. So while I am executing, if you are executing some program, so the binary files will be created. Okay. So this is what happened once you extract the file. Okay. So now the extraction is over, and next we should go and integrate with how to create the project, and how to create the project, and how to integrate it. How to create the project and how to integrate your project with your cloud SIM, right? So there are different ways are there. Uh, I'm just showing the first way. First, you just go with the file and go with the new project. Okay. So this is your new project, and select a new project, and next select next, and give your project name. Okay. So now I am giving a test the cloud sim project, and here there are two ways are there. This is one way. Okay, there are one more way also available. This is the first model I'm just showing. So this is using default selection. So please select this one, and you have to select where is your exact cloud sim softwares are available. Okay, where is your exact cloud sim softwares are available. So in there is, I have one more folder there. I have downloaded this cloud sim software, and I have just renamed with the csim. Okay, so here also you can see that the same thing what we have seen while extracting the previous one. Okay, so now I am just selecting this folder. So once you have extracted, once your extraction is over, you have to give that folder name. You have to link that folder name with this Eclipse workspace. Then you have to give select folder. So there is one more project is already available. Here it is existing. So no need to give this one. So we can give some other. I'm giving one more. So in this E drive, I'm giving one more name. Just wait. So I'm just taking one more copy. Now I have given a new name, CloudSIM new. Now I'm just selecting this one. So next I'm giving this new project. Just take CloudSIM new. So this is what I have extracted in the CloudSIM. So just I have extracted and I have just copied the content, and I'm just clicking this folder and I'm giving select folder, right? So one select folder, you just move to next. No need to this one, and you just take you finish, right? So this is our new project. So that a new project is enabled with the CloudSIM. Okay, I told that in CloudSIM, the CloudSIM software itself, it is providing some sample programs for execution purpose. We can utilize that program for understanding purpose. So all the programs will be available in the sources. Okay, so all the programs will be available in the sources, and you can see a lot of jar files also. Okay, so these are the jar files we have added. Some examples, while when the user write their own program, sometimes they may expect they can add their own external jar programs also. Okay, and here itself you have to write your own program. So this is already I have put some programs within this sources. That's why it is coming FCSS, then PSO, round robin, SJF, and utils, right? Actually, once you actually download, you will get these fields only. These from CloudSIM, then you will get a core, you will get a predicates, you will get a distribution, list, network, data center, power list, power nodes, and util. Okay. So within the sources only, you have to create your files. You have to create your files, and you have to create your folder, or you have to. That means you will visually call it as it is a package. Create your package, and you just import your programs, right? So you just import your programs, and you can execute all the programs. Okay. Then I told that the CloudSIM is providing lot of sample programs for execution purpose. So this all the programs are here itself. Okay. So here you can just double click it, and you can see that programs. Here you can see the programs. Actually, here only your program is having only around some 250 lines or some 260 lines. But when you execute the program, when you execute this program, I told that nearly some thousands of lines will be executed. Okay, so there are a lot of small inbuilt function calls are there. That function call will go n number of function calls. For example, if I'm saying that, so we are just calling the cloud start simulation. So once this line is entered, there are a lot of calls will be happen. Okay, lot of calls means usually we have to create the data centers, and we have to create a host, and we have to create virtual machines, and we have to create cloudlets, and the cloudlets we have to assign to the virtual machines, and everything will happen. Everything will happen when executing this start simulation. Once the start simulation is over, again the start simulation, it is not a simple call. It will call almost all the functions which is available in the clouds. Okay, so there are a lot of, I told that whatever we are writing. So in the CloudSIM architecture, we saw that three layers, right? One is that the bottom layer, that is the engine, and the second layer is, I think it is a core component layer, and the third one is the users area, right? I told that in the middle layer, there are a lot of functions which is supporting your program. So all the classes are available here itself. So, okay, these are the predefined classes. These are the predefined Java classes which is supporting for execute your programs. right? There are a lot of things are there. So these are the codes which is supporting your programs. For example, if I am executing this program, Cloud Sim example 1, if I am executing this one, so in order to execute this one, so here most of the classes, these are the files are supporting for the execution of this program. Okay, so this is very simple program, and this is for Cloud Sim, and there is here also there is some functions also there, and Cloud Sim.java, then sim event, most probably we will use sim event.java. This code also will support. There are a lot of things are there. So this then networks. So networks also will this will support. Then provisioners. So usually, what is the use of this one? The provisioners. Usually the provisioners means, I told that you have to create a data center with some configuration, right? You have to create the what is the host, and within the host what is the within the host what is the processor, how many number of processing elements you want, and what is the bandwidth amount, and what is the RAM amount, everything you have to fix, right? So while executing your code, you are executing your code here, and automatically these functions will be called by default. Okay, so please keep in your mind. There are a lot of things are there. So here power models, then so a lot of things are there. You please explore it. So it will take more time to explore all the things. But for our simple example, while executing our example, so most of the programs, it will take it from the normal. I think sometimes the data center supporting it will be done at here. Data centers. Okay. Okay. So this is the basic structure, right? So this is the basic structure. So how to configure your Eclipse with the Cloud Sim? So please keep in your mind. First thing is you have to download Java. Second thing is you have to download Eclipse, and first you have to install Java. Then you have to install Eclipse software. Once the Eclipse software installed in your system, you will get a first page. You will get a go tour with Eclipse. You will get a one prompt message. So please close it, and you can go in the left hand side. You can see the file. Okay. So there you just click the file, and you have to create a project. Once the project is created, you have to select the folder, right? So the folder should be where you have extracted your Cloud Sim software. Where you have extracted your Cloud Sim software, that one only you have to select as a folder. Okay. So you just give that folder, and you just click it, OK, and finish. Okay. So that's it. Now your your Eclipse ID is ready to execute your cloud simulation programs. Okay. Now let's say I am simply I am executing one small program. Then we have to go and we have a simple glance about the important classes in this Cloud Sim. So in our program, we will use some classes and some methods also we will use. Let's see a small glimpse. Let's see a small introduction about what are the core classes we are using in the program. Okay, right. Now I'm executing the program, and you will get results like this. These are the results like this. Okay, so I will explain everything later. So I told that while executing your program, you should keep in your mind, think about the 5 to 6 things. Okay. So I will explain. So this is your result. Okay. So next time, just go back to this presentation. I hope everyone understand this. What are the software requirements for executing your Cloud Sim programs? Java, then IDE, as well as the Cloud Sim. Okay. Then next. So these are the very important classes, right? Let's see. This is not that. Your Cloud SIM documentation, right? So just please type in Google Cloud SIM documentation. There you will get that first link, Cloud SIM 3.0 API, right? So here you can find out all the necessary classes. I hope everyone will know this one, right? So this is Cloud SIM core, then Cloud SIM predicates, distribution, list, network, and everything. We have seen everything in the Cloud SIM, sorry, in the Eclipse, in the Eclipse, right? Because once you have integrated with the Eclipse with the Cloud SIM, automatically you will get all the packages, right? You will get all the packages. And let's see, I'm just exploring a small one. So I'm just clicking this Cloud SIM, right? So in this Cloud SIM, you may find all the classes. These are the classes are very, very important. These are the classes are very, very important. And no need to study all the things. So most of the things are already it is existing only, and you just reconfigure it while writing your code. Okay. So I'm just giving some important classes what we are using in our programs. So first one is this cloudlet. Usually the cloudlet is nothing but it is basically it is a job, right? So when you write a program, you will say that this much amount of task I have to execute. Here the task is nothing but it is a cloudlet. Actually cloudlet it is a separate class. If you click it, the cloudlet have a separate methods. They have their own field. If you click the cloudlet, cloudlet is a class. Cloudlet is a class. Within the cloudlet, you can find n number of fields, and you can find out their constructors, how to call the constructors, and there are different types of methods are also available. Okay. So if I am creating a cloudlet means what is a cloudlet? It is a task, right? So for that task, these are the constructors. Okay, once you if you want to create a cloudlet, there are four different models of cloudlet creations are there. These are the constructor calls. I hope those who are familiar with the Java, you all know about this one. So cloudlet, first thing is you have to give us ID, then you have to specify that cloudlet learn. So the cloudlet length is usually will represent in billion instruction per second. I hope this word is familiar. MIPS, MIPS, billion instructions per second, and you have to mention what is how many number of processing elements you want to execute this cloudlet. Whether you want one processor, whether you want two processor, whether you want three processor, everything you have to mention it here. And next one is a cloudlet file size. What is the input size and what is the output size? Sometimes you may go with some reading and writing programs. That time you have to mention it. The file size you have to mention it. The next one is what is the utilization. So these are the predefined classes. These are the predefined classes. So how the utilization has to be happen. CPU, how to do the CPU, whether it is a time shared or whether it is a space shared, and everything you have to mention. And here also this RAM also, and you have to mention the bandwidth, because cloudlets we have to sometimes we have to we will allocate from one virtual machine to another virtual machine. So that time we have to send it to one VM to another VM, or sometimes we have to send it from one data center to another data center. So in that case, we should represent the bandwidth also. We have to mention it, right? So there are this is one basic model. This is one basic model of cloudlet, and we just read it. So there are other different types of cloudlet models also available. Please select anyone, right? And I told that because in our example we will see about the execution time, because we are going with the scheduling. So usually the scheduling means everyone will know that what is while submitting the task, you may find out what is that their what is the task of first, what is the waiting time of task 1, or what is the CPU execution time of task 1, and what is the turnaround time of task 1. Okay, so we have to find out all these things, right? And everything we can do it with the help of these methods. Okay, there are a lot of methods also there. You just see that to get the actual CPU time, how much it is actually executed. Then you can get the resource name, where resource name means it will specify, I think, three things. I think user ID, their broker ID, as well as their cloudlet ID also. Then cloudlet file size, then cloudlet history, that will give the whole history about the cloudlet object. Then cloudlet length, what is a cloudlet length, then what is the output size, and everything we can find out. So what is this cost per, get the cost per second. So usually the virtual machines, once it is executing in data centers so usually it will be executed in the data centers, and the data center cost will be different. Sometimes you may told that per second for a RAM, you can ask for 3 rupees. You can assign the values. You can find out. So what is the cost of a particular cost of cloudlet in a particular machine, that you can find out with the help of just cost per second, and what is the execution start time, and what is the finish time. You can find out lot of methods. So that is so it is if you select whatever method you want for your own purpose. Okay, you can find out the waiting time, you can find all these things, right? What is the start execution start time, what is your the start execution finish time, and everything we can find out. So here the documentation is also available. So this is one basic cloudlet. So cloudlet is a very important one. So this is one I'm giving. There is a basic one. So cloudlet, then so cloud sim is and another one important one. Okay, so through this cloud sim only we can start our project. That means usually our simulation will start with this cloud sim dot start simulation, and we can stop it also. So cloud sim dot stop simulation. So this is very important package, and you can find out all the fields, what are the fields are available, and what are the constructors, and what are the methods are available. You can find out, right? And get identity, and is passed, then you can pass the simulation. How much amount of you can pass the simulation. You can resume the simulation. You see that you can run the simulation, you can start the simulation, everything will be available. See that this is start the simulation. Once this is encountered, automatically your actual cloud simulation will start at this point, and you can stop the simulation. Once the simulation execution is over, and you have to track everything, and you have to save it into the cloudlet received list. We have to collect all the information. So from that information only we can print all the results, right? So this is another one important package in CloudSync. This is another one important CloudSync package in CloudSync. Then one more important thing is data centers. Okay, data centers are another one important package. And here only you will create your host, right? Here only you will create your host. You see that get a host list. You can create your host, everything, and you have to add all the host list within the data centers. Okay, right? And you can see get all the VM list. What are all the virtual machines are running in the data center? We can find out all the virtual machine list. So everything we can find out, right? Then data center broker, that is another one important package. So usually the user will write so many programs. Usually the user will write the scheduling programs or any simulation programs. The broker is a very important one. So usually the scheduling task usually will happen with the help of this data center broker only, because once your job is submitted, the broker has to assign the job. To data center. From the data center broker only, it will allocate the job to the host, and from the host to it will move to all the virtual machines. Okay, so while writing the scheduling program, you have to think about this data center broker. Okay, so while writing your code, you should think about this data center broker. And while writing all the code, those who are writing their simulation, especially for the scheduling simulation, they have to inherit the properties from the data center broker. Okay, we need all the properties of this data center broker. At the same time, we have to write our own code for scheduling all our virtual machines to the we have to schedule our virtual machine to the cloudlet to the virtual machines. Okay, so the cloud data center, that is another one important entity in the cloud scene. Then PE, PE means processing element. PE means a processing element we will use in programs. Right. I think, and one more thing is a VM. VM is another one important class and another one important package. Through this only we can create our virtual machines. There you can see that each virtual machine have an ID, each virtual machine user ID. What is that user ID? So while executing your program, there are n number of users will be there. User 1, user 2, user 3, user 4, or any number of users, and you should identify which users virtual machine this one. Whether the virtual machine is from user 1 or user 2 or user 3, that we have to identify. That you have to identify with the help of this int user ID. Then every virtual machine also having their million instructions per second. How many? Whether what is the capability of a virtual machine? Whether it is 100 MIPS per second or 2000 MIPS per second or 10,000 MIPS per second. That is how to decide it. The number of PES. That also you know that. What is that PES? The number of processing elements for a single virtual machine. Whether the VM has one processing element or two processing element or three processing element, that you have to fix it here. Then what is the RAM size? What is the RAM size? How much amount of RAM size to execute this virtual machine? Then bandwidth. Then you have to specify the size of this virtual machine, whether it is 1 GB or 2 GB. Then we have to specify. Then next one is a virtual machine monitor. So whether it is a string Zen monitor, Zen, or there are different types of VM virtual machine software also there that you have to specify. Then the next one is a cloudlet scheduler, right? So these are the important classes while writing the code. These packages we will use it in our programs. In most of the programs we will use all these things. Okay, so this is some basic introduction about the programming basics. Okay, because while writing the code, at least you should remember these are the important classes are available and these are the important methods are available. So according to our need, we have to use our classes, and we have to use the methods which is available in the cloud sim, right? And these are the major classes usually: VM allocation policy, VM scheduler, cloud sim, and most of the things we saw that. So future queue means what are the future queue means that is the waiting queue. What are the jobs are available in the waiting queue? Deferred queue means if suppose the cloudlets are stopped or paused, that kind of information we can identify from this deferred queue. And cloud information service, actually the cloud information service it is another one important operation which will start at the initial time. Okay, usually cloud information service means all the entities in the cloud computing should be registered with the cloud information service. Without the knowledge of cloud information service, we can't do anything. For example, if I have the data center must register with the cloud information service. So all these things will happen indirectly while calling your program. Okay, so you have no need to worry about this cloud information service, whether you want to write our own class or whether you want to write our separate class. Don't think about that one. So everything is already there. While calling the default function, automatically your resources will be registered with the cloud information services. Then SIM entity, then cloud SIM task, then SIM event. A lot of classes also there. And cloudlet scheduler, data center broker, data center characteristics. So what is meant by data center characteristics? You can specify that whether the data center is based on Linux based or whether it is 64-bit machines or 32-bit machines. Then what type of virtual machine monitor, whether it is Zen based virtual machine monitor, that you have to mention it. Then host, then network topology, RAM provisioner, then bandwidth provisioner, then VM. So these are the basic classes while writing the code, while writing our code, and we should use all the predefined classes. Okay, and this one. So this is working of Cloud SIM. So how to start my program? How to start my program? Please follow these steps. Okay, so don't bother about this begin and end. And first thing is we have to initialize a Cloud SIM package. We have to initialize a Cloud SIM package that we did. And Cloud SIM, first we have integrated. The next one is initialize the Cloud SIM package. How to initialize the package Cloud SIM? There is one function is available in Cloud SIM. The function name is called as cloudsim.init. Init means initialization. We have to start our Cloud SIM software, or we have to start our Cloud SIM, right? So through this only we can initialize the Cloud SIM. So the function name is cloudsim.init, INIT, with 3 parameters. We have to mention and today's date, and we have to specify the instance, and one more parameter also we will give. Based on that value only the Cloud SIM will be started. That is your the starting stage. That means your simulation is started. You are just starting your Cloud SIM, right? Then the important thing is we have to create the data centers. We have to create our data center. That is your first process. And second one is we have to create the brokers. What is the use of brokers? Brokers are act as these are indirectly it is act as the users, right? So because the users only usually the users only submit their tasks, right? So the once the users tasks are submitted to the brokers has to assign the task to the virtual machines or the data centers. Okay, so that is the second point, that is the creation of brokers. And the third one is we have to do the creation of virtual machines. We have to create the creation of virtual machines. We saw that a virtual machine, we have a separate construction, we have a separate constructors are there. VM of, we have to specify the ID, we have to specify the MIPS value, and we have to specify the RAM size, we have to specify the processing element, and everything we have to specify in virtual machine. Next one is the creation of cloudlets, and that also we saw that. And once all the operation is over, then you can go for start the simulation. You can do the start simulation with the help of Cloud SIM. Cloud SIM dot start simulation, and once it is over, you can go for stop simulation. You can go for the stop simulation, and finally you will get the results, output results also you will get, right? So these are some basic information about the Cloud SIM, and these are some important classes which is available in the Cloud SIM, right? And for this presentation, I am just selecting the programming demo. I'm just using first in first out. That means first come first serve. And here I am using the supporting softwares are Java, Eclipse, as well as in Cloud SIM 3.0.3. All right. So already we have created. What is it? Already we have created our projects. Then test new project. Within the test new project, So how to create our new projects? Okay, so the very easy way is just right click it and you just show in, and you please go to System Explorer. Okay, within the System Explorer you just please go it, and automatically this will go to your folder, right? So where you selected the Cloud SIM package, the extraction folder, in where is the extraction folder, that folder automatically it will move. Just double click it, and you just take sources, their sources. Already I have created the program, and I have just copied that program. Okay, so FCSS, there I have created 2 files. You can create the Java files. So Java file is very easy. You just right click it, go with the new, create a text document, and once the text document is created, you have to finally you have to save the program with .java. Okay, so that only you should keep in your mind. So that's it. So now I have copied and I have created a package. I have created the package first come first serve, that is a package. Within the package I have created two Java programs. Okay, now this is the creation. Now I am just coming to the sources. Now I am just coming to first come first serve. Now I can see that two programs. Right. So I'm going to execute these two programs only, and for this execution purpose, if I want to execute these two programs, means there are some dependency file also you can create. For that I have created one more folder. That folder name is also called as utils. Okay, so util, again within the sources we have to create. I told that whatever files you needed, you create a folder and you just create a file, Java files, whatever files you want, you please keep everything there. Okay, so this is first come first serve. I have created a folder and I have created two files, two Java files, and the supporting folders. There are, sorry, it is not a supporting folder. There is a supporting files that is also which is available in the another one folder that is called as utils. So while executing this program, this will access something from these three classes. These are the Java classes. You can select something from these classes also. Okay. So first I am just selecting the cloud scheduler. Okay. So this is our actual program. This is our actual program. This is our starting point also. Right. So there are one more program. Another program is a data center broker. I told that while executing your program, you have to inherit some properties from the normal data center broker. Okay. So this first come first serve data center broker, it is inheriting some properties. It is inheriting some properties from the normal data center broker. You see that first line. You see that. First come first serve data center broker, it is my own data center broker, that is extending data center broker. I told that you have to write your own policy, how to schedule your programs, or how to schedule your virtual machines, or how to schedule your tasks. Okay, so let's let's start with first come first serve scheduler.java. So usually in Java, actually the first program, what is that, the first program? Usually the programs always will start with main statement. Okay, so this is your main statement. So this is your first execution part. Okay, so this is the execution part. Let's see one by one. So in my scenario, I am creating 5 data centers, okay, and I am creating 30 cloudlets. Okay, 5 data centers and I am creating 30 cloudlets. That means 30 tasks. Okay, so I'm just showing, so that I have mentioned as that Java, sorry, constant at Java, that I have specifies. Okay, so this is first one is here it is the number of tasks, that is actually it is the cloudlet. Okay, and the second thing is, so third one is no need for our first come first serve. So here only I am using, so I am just using number of cloudlets. I am taking 30 cloudlets and the number of data centers are 5. Okay, now first part. See, the first one is new generate matrix. Okay, so what is that new generate matrix? So new generate matrix is a function call, right? Or it is not a function, it is a constructor call. New generator matrix. What is the generate matrix? Generate matrix is here itself. Okay, now it is coming and it is generating the first one. Okay, so generate matrix. So this one is, it is initializing. This one is first one part is initializing. What is first one is initializing? First I am creating what is that? First I am creating the task. Okay, first I am creating the task. There I am using two matrix. One is communication time matrix and another one is execution time matrix. Based on these two matrix only, I am creating my cloudlet. Okay, I am creating my cloudlet. Right. So generate matrix over. Next, I'm just executing this get exe matrix. So generate matrix dot get exe matrix, automatically again it will come here. Exe matrix, read cast matrix. Yes, just a minute. Get exe matrix.
Sir, we can't see a screen.
Oh, its screen is not visible to you, huh? Wait. I will share one more time. Now is it visible?
Right, sir, yes. The team
Yeah,
screen
okay.
is visible. You can change it to the browser.
Yeah, now are you able to see that Eclipse?
Yes.
Yeah, okay, right. Now I am creating two matrix, right? So one is the communication time matrix and another one is execution time matrix. Then generate matrix. So generate matrix, it is generating these two matrices. What is that matrix size? Number of tasks and number of data centers. You know that number of tasks and number of data centers. So it is creating 5 rows and 5 columns. This is creating 5 rows and 5 columns. I will just show what is the output. I will show what is just showing what is the output. So previously the program has been run.
Sir, we can't able to see your executions and all.
Okay. Now is it visible now? No.
Just we are seeing on folder page only. That is STFS.
Okay. Now is it visible?
Yes, right.
No.
Yes, it is visible.
No,
So
ma'am,
if
is it
this
visible?
Eclipse window is visible to you, please type yes.
Not visible, sir.
Ma'am, hope only for you the problem is, please you can refresh the
No.
screen or you can leave and get inside again. For others it is yes. Right,
Others
sir?
getting, yeah.
You can continue, sir.
Okay. All right. Now, where I have. So these two matrices are generating. So generate matrix dot get exe matrix, and another one is generate get com matrix. So both classes are I have written here. Get matrix. I'm just calling. Right. So this is a generate matrix, and you can generate the matrix, then read cast matrix. So if the file is not available, if this file is not available, it will create the new values. Otherwise, it will take our old values. Okay, and you need to cast matrix is a generation will be like this. What is the cast matrix is I'm just generating some math dot random into 600 plus 20. So this value is generating uh, because we have created 30 tasks, right? We have created 30 tasks, and we are using 5 rows. We have not 5 rows. We are using 5 data centers. So it will generate 5 into 30, around 150 values it will generate. Okay. So all the things, whatever you are writing, everything will comes under this communication time matrix as well as the execution time matrix. Okay. I will show you. Then scheduler. So now this task is over. So why I am creating this execution matrix as well as a get common matrix is I have to create the cloudlet. So for that purpose only, I am randomly generating some values. I am randomly generating some values. For that only, I am using this one. Okay. Once the random generation, once the random values are generated, next time what I'm going to do is I'm going to create the data center users, right? So grid users. Now I am creating. So in this example, there is only one user. Keep in your mind, there is only one user, 30 cloudlets and 5 data centers, right? And I told that initially, I told that cloud sim we have to initialize. We have to initialize our cloud sim package with the help of 3 parameters. What are the parameters? First one is what is the grid user name and what is the instance, and we have to trace. So initially the trace value will be flag value will be in the false value because it is not yet started. So now your cloud sim is initiated. Okay, and in the previous flow chart, you know that first step is we have to create the data centers. We have to create our data centers. So the data center creation will be like this. Data center creation will be like this. So data center equal to new data center of constant dot number of data centers. So automatically new data center of 5, right? So now data center of 5. It is a single dimension array. There I am creating data center dot create a data center. Okay, you can also see that a data center, how the code, how the where is that code? See that this is a data center creator. Okay, so here only I am just creating the data center. So see that here I am using the data center creator. This is the function call. Once I am giving the function call, automatically it is coming here. It is for creating the data center, right? So within the data center, what are the things we have to do? Just to see that, right? So first I am creating the host list. What is the use of host list? I told that within the data center you can create one host or 2 hosts, or you can create 3 hosts, n number of hosts you can create, right? And the next one is we have to specify the processing elements, right? And next one is we have to specify the MIPS value, and we have to add all the processing element with the new one. So create the processing element and we have to add to the list, right? So you can create n number of processing list and you have to assign to this processing elements to the host machines, right? So next one I am just assigning the host ID. Host ID is 0. Then I am specifying the RAM size. Then your host storage size and your bandwidth also. Integer RAM is a 2048, means your host is having 2 GB of RAM. Okay. And next, what I am doing is I am just adding whatever host I am creating. I am just adding with the host list. So within the data center, there will be the host, and you can there is a possibility for creating n number of hosts. So in this example, I am using only one host. So host ID, then I have to specify the RAM, then I have to specify the bandwidth, then I have to specify the storage and how many number of processing elements. How many number of processing elements? Because every processing element have an ID value. Every processing element have an ID value, and we have to specify whether within the host you can create n number of virtual machines. You can create n number of virtual machines, and you have to specify whether your virtual machine is time shared or the space shared. So within the in our first this scheduling algorithm, we will use it is based on time shared concept, right? And one more thing I told that we have to specify the characteristics of the data center, right? So we have to specify the characteristics of the data center. It is x86, right? 32-bit or 62-bit, and we have to specify whether it is a Linux-based system, and we have to specify whether it is a virtual machine monitor, whether it is a Zen, or there are other type of virtual machine monitors also available. And the time zone, if you want, you please give. Then these are the cost. What is the cost amount? I told that while executing the cloudlet, it will take some amount of time, and it will take some amount of storage space, and it will take some amount of RAM space. It will take some amount of processing elements. So what is the cost? And everything you have to mention. This is cost per memory, and this is cost per storage, and you have to cost by the bandwidth also. You have to mention it, right? And if you have n number of storage elements are available, you just please go with the linked list also, right? And finally, you have to specify the data center characteristics. So here only you are specifying the characteristics. So These are the characteristics are associated with the data center. Okay, so you have to specify the architecture, what is the OS, what is the virtual machine monitor, and you have to specify everything. The host list, you know that if in your system there is only one host, so within the host list it is array list, right? It will have 1 or 2 or 3 or any number of hosts you can add it, right? And finally you have to create the data center. Once the data center creation is over, I am just returning the data center. So data center, what will happen? So whenever you are calling, so we are creating 5 data centers. So 5 times this will be executed and you will get 5 data centers. So data center 0, data center 1, data center 2, data center 3, and data center 4. Okay. And next one, we have to create a broker. I told that what is the use of broker? Instead of user, we are using the broker. Okay, so broker only has to take care of all your working units. Take care of all your working units. So we have to create a broker ID. Usually the broker ID. So the system will automatically it will generate. Right. So that is the second thing. We have to create a broker. So we have created the data centers, and within the data center we have created the host, and the next one is we have created the broker also. Right. So create broker. We can go for the implementation. This is the broker creation. First in, first out. There is a separate broker we are creating. I told that data center broker. So the data center broker is a default one. We are creating our own data center, right? We are creating our own data center. So we have to extract it. We have to see that first come first is the data center broker extends our data center broker. That means you are creating a data center broker. That broker is extending. That means it is taking most of the functionalities from the normal data center. So the first come first serve data center having all the capability, whatever activities can do in the data center broker, all the activities can also do with the this FCFS data center broker also, right? So that is a data center broker. I think yes, here the data center broker, and we have to create the data center broker also. And next one is we have to create a VM list, and you all know that this create VM. Create VM is another one method, and we are just giving broker ID. What is a broker ID? And we have to specify the number of data centers. You know that VM list, because we have to create the virtual machine list within the data centers. Next, we have to specify the cloudlet list. Cloudlet list is we have to create our cloudlet. So with the help of broker ID, and we have to specify the number of tasks. Usually, so 30 cloudlets will be created. So 30 cloudlets. So number of tasks will be 30. So 30 cloudlets will be created with the help of within a single broker ID, because user is one, broker is also one. So I am creating 30 cloudlets and comes under a broker ID, right? So next time what I am doing is a broker dot submit virtual machine list. So broker dot submit virtual machine list. Here what I am doing is I am just submitting the virtual machine list to the broker. Okay. So broker having the cloudlets, brokers having the host, brokers having their internal virtual machines, everything comes under the broker. So within the broker, I am just submitting my virtual machine list. So within my machine, I am having some so whatever virtual machine. So here virtual machine means so totally 5 virtual machines will be created, and the 5 virtual machines will be added with the broker, and broker dot submit a clouded list. How many clouded list is available? There are around 30 tasks. There are around 30 cloudlets are available. So that is also added with the broker. Okay. Now, before the simulation starting, the simulation, please keep in your mind, you are just creating a data center, you are creating the host, you are creating the virtual machine, you are creating the cloudlet. So cloudlet you can also directly create, no problem. So here in my example, I am using a separate generate matrix. So through that I am just creating I'm just creating the values, the cloudlet values I am generating, right? So once the cloud sim starts simulation, so once it is started, automatically the cloud start simulation will calls the data center broker internally. Automatically it will calls the internally, it will calls the data center broker. So in the data center broker, we are having our own data center. Sorry, we are having our own data center. That means the cloud scheduling policy. There are cloud scheduling policy. So this is the actual scheduling the VM task. And once I am starting the cloud start simulation, once it is starting the cloud start simulation, this method will be fetched automatically. First, this method only it will fetch. Okay. So once you are submitting the cloud task to the broker and you are starting the simulation, and you have to assign the cloudlets, and you have to assign the virtual machines to the data centers. So that only I am just mentioning. Okay. So cloudlet.ev, EV means it is a simulation event data, and you are just printing the values, whether your cloudlets are received with what, whether your this is a cloud sim data clock, at what time your cloudlets are received with the data centers, whether your cloudlet is received within the broker or whether your cloudlet is received by the data center, and everything we have to mention it here. Once it is submitted, and immediately we have to do the subtraction operation, because you have created 30 data center, whether all the data centers are whether all the cloudlets are assigned to the virtual machines and the data centers, that we have to discuss. Okay, that we have to decide. Okay, so this task will be continuously, it will be executing. Once all the cloudlet tasks are assigned to the virtual machines, then you can go for the scheduling the VMs. Once all the cloudlets are received by the data centers, or once all the cloudlets are received by the broker, you can go for the scheduling the task to the VMs. Okay, so now we are just scheduling the task to the VMs with the help of this function. So schedule task VMs. So this is our schedule task VMs, right? So finally, I'm just set cloud received list of C list, and this is C list only. Finally, I'm just assigning all the tasks to the virtual machine. Okay. So once the virtual machine tasks are over, so C list is nothing but this is a cloudlet list. C list is nothing but it is a cloudlet list. So within the cloudlet list, all the cloudlets are submitted. Now the C list having all the cloudlets, and you are just calling the method name is set cloud received list. And once the function call is over, automatically all the cloudlets are assigned to the virtual machines. Okay. So next process is the cloud execution process. Once you have once you are submitted all the tasks to the virtual machines, so all the tasks are executed one by one by the virtual machines, those who are available in the data centers. Okay. So again, every time it is again, so the cloudlets are executed. So every time the cloudlets are executing, once the execution is over, you will get a message like this: all the cloudlets are executed and it is finishing. Once the cloudlets are executed within the data center, automatically you will say that it is clearing the data center. That means the data center works are already, it is over. Okay. So the clear the data center, and it is also, we are just finishing the execution also. So once the execution, all the execution is over, every execution is over, all the contents will be saved in one place. Okay, all the informations will be saved in one place, that we will see in this next one. Right. So now this cloud data received list, it is having all the informations. Okay. Next, I am just doing the stop the simulation. Now, once the start simulation, I told that the start simulation, once the start simulation is working, once it is started, this start simulation, it is calling the data center broker. Don't think that only the data center broker functions are running automatically here. Inside of that, everyone, this cloud execution will call one function. This is schedule VM task. This is already, there is a predefined function. Sorry, it is not a predefined function. It is a user defined function. So again, this will call, and there are so many calls will happen within the cloud sim, right? Once all the executions are over, we are just doing cloud sim dot stop simulation, right? Right. So next what I am doing is whatever contents, whatever the status or get it from the data centers, everything will be saved it into print clouded list. Okay, so within the print clouded list, that is the new, sorry. Okay. So this is a new list. Within the new list only, the brokers are giving all the things. So we are just calling broker dot get cloudlet received list. That means whatever things are received by the broker, now the broker is assigning the task to the virtual machines. Once the virtual machines are executed your task, and all the informations are set back to the broker, and the broker will assign all the values to the new list. Okay. Now new list, why I am using a new list? Because it is a list because we are having around 30 cloudlets. We are having 30 cloudlets, and this is executed in various virtual machines. It is executed in various virtual machines, and it is we need the exact status. What is the submission time, and what is the execution time, and what is the waiting time, and everything we have to discuss, right? So for that only we are using this broker dot get cloud received list. What is the use of this get cloud received list? This will extract the contents from the what is that cloudlets. We need the status. We want to identify the status of cloudlet, right? Right. So once it is over, I am just calling the print cloudlet. Okay. So I am just calling the print cloudlet. This is our own method. We are just printing the messages. We have to printing the messages. So don't think about this one. This is a cloudlet ID. What is a data center ID? What is their VM ID? What is their starting time and what is their finishing time? So that only we are going to print, right? So we are expecting only the cloudlet with the success, right? So we are just printing all the values with the success, and this is very important. This is also very, very important. You just take what is the resource ID, and we need the get VM ID. What is the use of this one? You need you want to identify about what is a cloudlet ID and what is the VM ID, where the cloudlet is executed. Okay, so for that purpose only I am using this resource ID, I am using this virtual machine ID, and I am getting what is actual CPU time, right? What is, you know that those who are studied in OS, I think most of them are familiar. What is their get actual CPU time? So within the system, you can submit n number of tasks. You can submit n number of tasks. So every task, so once the submission is over, so the system won't take the task immediately. It will take some time. Maybe it will be in the queue, right? So actual execution time is what is, how much time it is executed in the CPU, right? And execution when it is executed. So that is the starting time. So you can identify what is the waiting time. You can find out, right? What is the waiting time? Get exe start time minus get exe, sorry, get actual CPU time. Okay, and you are just finding what is the get finishing time. So everything we are sorry, so we are identifying through this cloudlet. Okay, so these are the predefined methods in the cloudlet. I think we discussed this one, get a virtual machine ID, where the cloudlet is executed, and what is the actual CPU time, and what is the execution start time. And you can also find out the execution. You can also find out that waiting time also, I think. Sorry, it is not cloudlet dot. You can find all the methods. See that actual CPU time. You can find out that waiting method also. See that? If you are using this one, waiting time also you can find out. Okay, so in our example, I am not specifying that the waiting time. You can also better, you can calculate the waiting time. Usually in first come first serve, we will find out what is that waiting time, what is the average waiting time, what is the turnaround time, what is the execution of all the machines, that you can find out, right? So if you want, you can use this get cloudlet dot get waiting time. You will find out the virtual machine one, sorry, cloudlet one, how much time it is waited, right? So everything we can find out. So if you want, you can add it. I'm just running the program and we will get a result. So these are the results. So cloudlet 0 and it's executed in the data center ID 1 and the virtual machine ID, and this is their starting execution time, and it is started, like we can see it from here also, right? So data centers, how many data centers? Totally 4 data centers are starting, and your brokers also started, and we have to assign, trying to create the virtual machines. We are trying to create our virtual machines. Then brokers, virtual machines are created in the data centers. So brokers only, it is taking care of the virtual machines assignment. Virtual machines assignments in which data center. Okay, so that is done with the help of. So all these are when it will happen. This is 0.1 time. 0.1 time automatically all the virtual machines are created. Then from 0 to onwards, what is happening here? 0 to onwards, it is sending the cloudlets to the virtual machines. Right? These are the timing elements. At the 0th time, what will happen? At 1 second, what is the actions is happening at the cloud scenario? These are at a second time. Sorry, time is 2 seconds. From 2 seconds onwards, what is happening? And you can see that. So 1706 seconds. These are 1706 seconds. What is happening? These are cloudlet 2 is received. Okay, so cloudlet 2 is received in broker 0. Then cloudlet 1 is received. So all these messages are printing. Once everything's are over, once all the cloudlets executions are over, received means what? Cloudlet executions are over, and it is resubmitting to the broker. Okay, so now all the cloudlets are executed, and once the execution is over, I am just destroying all the virtual machines. Once the virtual machine is over, I am just shutting down my broker. There is no simulation events. Then all the data centers also I am just shutting down, and the simulations also get over, and you can find the results. Okay, so these are the first come first serve execution. So here you can go with it. So usually in exercise, usually in the normal exercise, we will use what is the average waiting time of these 5 tasks, and what is the average waiting time of what is the average execution time. That also we can find out. There you have to write a separate logic here. You have to write a separate logic. You just create a new variable with anyone, and this is a loop only. Within the loop only, you can get what is the actual CPU time. You can add all the values. You can just divide it by 30, and you can find out that actual CPU time and what is the average waiting time, and you can also get the average average execution time also you can find out. So that's it. This is the simple first in first out execution in this cloud sim scenario, right? And if you have any questions, you can please ask me. Right, thank you.
Participants, so you can raise your queries either through chat window or you can make hand raise. Bright sir, there are lots of feedback mentioned in the chat window, mentioning very nice session.
Yeah, thank you all.
Right, sir. There is one question. What is the use of indent, sir?
Intent is just a spacing, ma'am. Actually, in that program, there is a spacing I am using, right? I think there is a spacing is available. Intent means it is just a, you see that I'm just showing, right? I'm just showing this one. See that intent is just a space only. Just a space. String dot intent is just a space, because I have to display the result, right? So I need some spaces. For that only I am using the intent. For better viewing only I am using that string variable. Okay.
Any other questions?
So the question is, do we need a flank and jar file for executing program? In some versions, it asks to include that in package. Actually, so jar file inclusion, everything is up to you only. Right. For example, if I am creating my program, in that program it is expecting there is a jar file math common math dot 3. There is a separate jar file needed, means you can go and import that package. So what is the use of jar? Jar is having already some predefined packages, and there is some predefined classes are available that will support for your code. For that only we are using the jar. So that is up to you, ma'am. Actually, the jar files are, everything is up to you. If you need, you just create a jar file and you just add with your project. But do we need a flangen.jar file? But I am not using this flangen jar file. But it is, I don't know whether it is a mandatory one or not. No, exactly. But Cloud SIM is very important, because a Cloud SIM jar file we have to we must include that jar file. And if you need any other additional jar files, you can add it. Yes, sir. Cloud SIM is an open source. Yes, 100% it is a pure open source software only.
There are so many positive feedback. Dear participants, any other questions? Please raise it. Can
The
do
feedback link is
experiments.
shared in the chat window.
Can you do experiments to testing? Because we are doing
One question,
infrastructure service. Yeah, we are doing infrastructure as a service only. We are executing our task in the data centers only. Right, so it is almost it is similar to the infrastructure as a service only. We are executing some task, but we are this is the simulation only. We are executing our task within the simulation. For example, you can identify the cost. For example, if I have a cloudlet with this million instruction per second, and this much amount of RAM, this much amount of storage space, and this much amount of processing element. When you run the program within the Cloud SIM, you can calculate the cost value. You can identify the exact cost, right? So almost it is similar to infrastructure as a service only, because in cloud scenario, we will use all the resources as pay per usage model. How much we are using, we have to pay that. Okay. Similarly, when we execute our program with this, I told that while creating the VM, or while creating the host, or while creating the cloud, we can specify the size. What is that? Size means we are specifying the cost size. Through that, we can identify. So how much amount will take while executing your task within the real cloud scene, in the real cloud computing area. That means the real cloud, right? You will get almost you will get the same results. You will get the same pricing amount also, almost similar to the pricing amount. So that time it is very useful for you. I think.
One more question. Which one is better?
So for both cloud, I think these are the open questions. I think which is one is better, Amazon cloud or a Google cloud? So that is up to you, right? So we have to go and see that Amazon cloud as well as a Google cloud, because I am not using any cloud services, right? So I don't have any idea about this Amazon cloud or a Google cloud. Which one is better? Because I'm not using any services from Amazon cloud as well as a Google cloud. Because in this Google cloud, we are getting only a few services, like mail services we are getting. So that only we are using. I am also using. So I don't have the clear comparison between Amazon cloud and Google cloud. Actually, it throws an error when you didn't include that jar file in CloudSim, even are executing the sample examples. That's why I asked. Okay.
Excellent presentation, sir.
Thank you, ma'am. Thank you, all the participants. Thank you all. If you have any doubts, you can ask the questions.
Any other doubts? Feedback link is available in the chat window. Kindly fill the feedback. And the recorded videos of the previous session is available in the registration link. And today's video is recorded video will also be hosted very soon. So please watch it. Once again, I thank the resource person, Jose. It's a very excellent presentation and it's a very informative one. Hope that it will be understood by everyone. And also, I thank all the participants for your patient listening and also asking the questions related to this. Then I thank the organizing team, the management, especially Dr. R.P. Andrew Kumar sir, Anthony sir, as well as Varun sir. Thank you once again. Thank you all.
Thank you, ma'am. Thank you so much.
All the participants.
Ma'am, please continue.
Varun sir, if you want to say anything.
No, ma'am. Tomorrow also at the same time you use the same link and get into the FTP room.